So welcome back to our last session of our Python workshop, and we will look at topic modeling. But first we will about technical details. I added the video for the part 2 also to our GitHub repository. It should be up in about 10 or 15 minutes depending how quickly Google transcodes the video. So I noticed, I was happy to see that second part 1 was already watched a few times, so people are watching it. That's good. So I will also add the second and third part of yesterday as well when we have free time afterwards tonight. So, okay, so we'll continue with our last part. Maybe any questions in the chat on any technical details. So again, I can already tell you that out of this second part, for those who want credit, I will be asking for a word cloud. So word cloud, if you made your own word cloud, you are good, right? So, So yeah, so that's that. So okay, so we will proceed to the last part. I'll go to single screen and we'll open up this Colab modeling data. Open up a new window, and we will be talking about LDA, latent Dirichlet allocation. So for idea is to talk about how topics are grouped or clustered in some way, basically. And we'll be using Gensim library, and we'll be also using PyLDA visualization library. Out of all of these libraries, Gensim is included with Colab, which is good news, right? So which is good news. If you don't have Gensim, you will need to install it. So again, PyPy, let's check Gensim. It's a very popular library for language analysis, for some really nifty stuff. Let's see. For topic modeling, document indexing, similarity retrieval on corpora, on quite nice, right? So some nice algorithms in here. So very good. And so we'll take a look at the LDA today, right? So it's slightly intermediate topic already. So we'll do some cleaning, of course, as well. So we'll repeat some of the things we did before, today and yesterday, and then we can proceed to our actual main part, right? So, so Gensim is nice to know, but not necessary. So what is topic modeling? It is a machine learning technique, right? We try to discover topics, meaning words. Usually these are words that occur together in a body of text. They don't have to necessarily be words. It could be also bigrams or trigrams, possibly, depending how you prepare your data. So it is, you don't have to do much. It's unsupervised technique, meaning you don't need the answers yet, right? It tries to create the answers for you, basically. It's very similar to clustering. The clustering technique, basically. One difference between regular clustering and topic modeling with LDA is that you will get actually percentage answers. Using LDA, you get sort of confidence scores on where the topic, where the corpus, where the document belongs in which topic, right? So no document belongs in a single topic. Actually, it's spread across multiple topics, actually, using LDA, right? So, of course, it is an exploratory technique, meaning it is, you need to come up with your own labels, right? It'll just say topic label 1, topic label 2, topic 3, and so on, right? You have to figure out what this means, actually, or if it means anything. And of course, we have a question how well the grouping worked, actually. I mean, you can always, again, as we saw with word clouds, you can always come up with some meaning, right? Is it really a meaning, right? So we need some also metrics to say how well the clustering worked, right? So again, so we're not trying. We're not trying to predict where the document will lie, in which topic it belongs to. We're trying to sort of explore the space or corpus, basically. So there should be some links to read more. Again, there's a paper. I think, of course, Blay is a very, very influential figure in machine learning, and the same goes for Andrew Ng. This is a paper, original research paper, quite influential. NG works to Google now, of course. Now I went to Baidu, I believe now, and Blay also two big, very influential figures in machine learning community. So this is a very important paper actually. I think cited I don't know how many thousands of times, right? And this is actually this is a paper is how it's visualization paper. Very nice, useful paper here. So again, for something to explore more in detail. So again, as before, we need to import the data. So we need to import the data, and we still have, or we're going to use requests because again, so it works for everybody, and we will use for now. Again, depending on time, I will do with a bigger data set, which is what I want from you eventually. So we'll use pandas OS Gensim requests. Right, so let's see if everybody, okay, of course I have to run it. So pandas exists, OS exists, that's standard. Gensim might need to be installed using pip install Gensim, right? So again, if you're using Colab, right, it works. Let's check our Gensim version. That's a good point, right? So let's take a look. So we know pandas, right? Pandas, of course, is, I think it exists. Pandas version exists. I don't know if it exists. Yeah, 1.35, right? Again, we can do OS, doesn't it? So Gensim, is there a version? It should be. I don't know. 3.60. Again, we can check how far back we. Again, if something doesn't work, sometimes again something latest and greatest doesn't work. It probably has to do with the version, right? So Gensim is now up to 4.2. Again, so we can check our history. So I think it is from about 3 years back, 2 or 3 years back, 3.6, yeah, actually 4 years back, almost 4 years back. So some of the latest algorithms might not be present in this version in Google. You could always install a newer version actually using pip install if you need something latest and greatest. Okay, but for now we'll stick with this version on whatever Google provides. So I'm using URL, again same as before, nothing new here, right head. By now we know this process pretty well, and we have text, right? But there will be a difference. So here, since we are doing topic modeling, well, we're going to have to consider each document separately. When we're doing word clouds or frequency analysis, we basically took whole corpus together. We used join, we joined together, and then we perform some analysis. Here we are going to analyze. We're going to do analysis on each document. So each document will be one unit, basically. So we're going to list. So we're going to have again. So again, we have a list of strings so far. Strings so far, right? However, 499. Again, we'll use some. Again, in topic modeling, stop words are quite important because, in fact, quite crucial because you'll get a lot of topics with all these useless words, right? Again, even with built-in prevention, for some common words will not register as a useful topic word. You will still get some. Basically, every topic has maybe some common word. It doesn't really make. It's not very useful. Your topic, your model is not very useful. So we'll need to use that as well. So we have so raw documents, right? Again, type of raw documents is list, right? Just to make sure, right? It's a list, and again, document. Each document is like something we did before, right? On each document is a string so far, right? Okay, so it's a list of strings. Okay, it's useful to know because Gensim will need something. We'll need to do some preparation work, right? We need to figure out what Gensim needs, right? So first of all, we're going to do a stop list. Again, we're going to use Latvian one, and we're going to use again same idea before, like in the previous notebook. We're just going to load from directly from this master. Again, if you have more stop words, definitely we could use it. So we are going immediately, if 200, we start with a blank list. If you get a positive response, right, it works. We get stop words as response text split. And here it works fine because, of course, these words are prepared already, right? We can use regular good old split. Yeah. Okay, so now we are going to define, we have our stop words, we have our documents of strings, and we are going to need a function. Again, this you can make this as long or big as you want. Here it's a short function. What it's going to do? It's going to take each token, right? So it's going to take, if it's in a stop words, we return nothing, right? Returns nothing, returns none, return none, right? If length token less than 4, right? Yes. In fact, I would probably make it here default value. It says, okay, if it's a very short token, as we saw, those words rarely have any meaning. We return again none. And also, if it's not, so let's see, not. I think we could change it. Actually, we don't need the parentheses here, right? We don't need parentheses here. Those are not needed, right? So if it contains a token, right? Remember, if it does not contain, if it is, so it means if we have any non-alpha numeric, or actually alpha, is alpha is alphabetic, right? Yeah, alphabetic characters, right? And then we return nothing, right? So again, let's double check what does it mean. So this function from yesterday's string is alpha, right? Is correct, right? True. However, if I have something like, let's check, well, this is 5, right? Or Control Z, Control C, right? Let's say 35, right? And it's false, right? So yeah. So okay. So if you have any numbers, okay, for this purpose, again, it's up to you to decide what you do. You need numbers in your topics, right? Again, we have done some work where it's important, where these numbers actually have some significance. But here we're going to consider they don't have any meaning. Okay. So okay. So that's our function. So this again, this function yet is basically for processing. So how would we use if I do this, right? If I do what's it called, process token val this, right? What will I get back? What do you think? Let's check. Do you see what's going to be back? Will I get the original? Well, let's take a look. Oh, I didn't return it. I didn't learn it. So let's take a look what I get back. I get val this small. Why? Because to lower, if token, okay, it's not a stop word. Okay, that's good. Is it less than 4? It's good. This does not work. This does not work. Is it not an alpha? It doesn't work. And so after all this extra work, it returns this converted token, right? So I have a new token to work with. Okay. So yes. 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 Okay, good question. So here I think, let's see. Actually, in fact, here it would be exactly the same. In this particular reason, we could write elif, right? Because we always, or in fact, of course, since we in these 1, 2, 3, right? We could have done or, right? We could have checked here all 3. But for readability, right? Since we're returning here, right? It's mostly done for readability purpose. We could have done, this would be exactly the same in this purpose, right? Else if, right? Elif, right? And else, right? This would also work, right? This would be exactly the same. And else, this would be exactly the same, right? All this.
Yes.
You agree, right? Yeah, it would be exactly the same. So in this case, it just adds extra space because again, with return, we only have one return anyways, right? If you return from a function, you only have one. You have 4 ways of getting out, but it's only one of those will work, right? So using return, so-called early return, right here, there is no need to have the extra else if, right?
So it's a bit more readable.
It's a little bit tiny, a little bit more readable, right? You do have to be careful with these without else if, right? It can be dangerous if you're doing something you're not returning, right? You could be doing some extra work, right? You're doing multiple checks, basically. They're not, these 3 are completely independent checks, right? They have no, I mean, it's possible you do all 3 checks are positive, right? And if you're not returning, right, you could be doing some extra stuff. And again, it really depends on your what you need to do.
Basically, that's filter.
Yes, yes. Okay, so this is basically in comes something, out comes something. In this case, this something is going to be either lowercase or nothing, right? So we can process, right? So again, if I can show you, if I do this, process val, this process token, val, this, right? It's nothing. I get nothing basically. Okay, so this is a little, it's not a function yet, but it's basically a little code cell. So we have limit is none, right? He has no limit. So I don't think actually we use this actually. Do we use limit here? No. Okay, so we have documents, right? We have a list. Let's start with a fresh list of documents. You know, blank list of a blank list of documents, right? And we go through the raw documents, which is a list, and we do this. Well, yeah. So this also would be good candidate. Good here. You could modify to use NLTK word tokenize again. This is another thing we can do if we have time, right? Get the split again. We know from experience by now that the split is not perfect. It's just a quick way of splitting in tokens, right? You can have more fancier tokenizers, right? Maybe even lemmatization, but then we have this. So we have tokens out of each document. So we get tokens out of each individual document, and then we make a new document. This is going to be a list. We create a list, right? We create a list of processed tokens for each document, right? And when I say document, of course, it's a newspaper article in this case, right? And then, when all this is done, well and done, we append each processed document to my big list of documents. So I go through all the raw documents and I process them, basically. Right? Again, this is extremely common, this type of workflow. You go through something, you do something, you append to a new something, basically. You have start with new list, right? You append whatever you did. So let's take a look. Yes, this is actually added by this is basically idea. There was a setting I think I should take it off. Basically, there was a setting if you did too many, you could set, it's not needed anymore. There was a setting if you went over the limit, basically to stop working, right? So, we clean this up, you don't need those, and let's run it. Okay, right, so you see it worked, right? Lowercase for now only, it's not lemmatized, but okay. You notice something interesting here, right? The second document is empty completely, right? Because why? Because it was an email, I believe. It was just a simple, the scraping was kind of raw, and I think it was not, there's nothing to keep, right? It's completely empty. Okay, on this again, this is the third article. Okay, so we have 3 articles, just an example. We have all of them, of course, right? We could check also the last one, right? Last 2, let's check last 2. So documents, let's check last 2 will be what? -2, right? This last 2. Let's check last 2 documents. Again, it's always do the soundness check, right? Check if everything looks okay. Again, right, looks okay. This is pretty big actually, right? Yeah, okay. Okay, now again, so Gensim needs this list, so it needs a list of documents, but each document has to be a list of tokens, of words. So you need a 2-dimensional list basically, right, to feed it in order to work. So we are ready. Of course, we could have lemmatized and so on, and now we're going to build a dictionary out of this, right? This is so basically this dictionary object. It's going to show, right? So mapping on basically again in order for this machine learning algorithm to work, right? It needs this. It creates a dictionary. It creates a mapping basically of tokens. It creates IDs, right? Again, which don't mean anything by themselves, but they need to map somehow to the words, right? Because of course most machine learning algorithms they don't work with words. They work with numbers, right? So you need some sort of ID, right, to map it. You run it, and then you see, okay, word number 3 was Valdis, word number 2 was Yuldis, and so on, right? So need some sort of mapping. And again, doing it by hand would be very painful, right? Okay, So how many documents do we have? So we have a dictionary, right? Documents. So document count is how many documents we have. We have 4099. Now this is the part which is the 7, right? 7 is just a wild guess here, right? Yeah. Now this is just a, so you will want to change this possibly to get better results, right? And passes is, this is the modeling. Let's see, you can adjust this assuming how much time you have for your computing, how much work you, how many times you want to do this, not retain, iterate over the model basically, right? So 5 is, I think, is about the minimum. We'll see in documentation what they recommend. I think 5 is a good recommendation. So, and then, okay, so here is an interesting setting, by the way, right? Filter extremes, right? So we are going to remove by default, these are default settings by default. By default, you can adjust this, by the way. I had adjusted this before. By default, remove terms, meaning that occur in less than 50 documents, and terms that occur in more than 90% documents. So we don't want a term which occurs in every document. Basically, it does not add meaningfully to our topic, basically. Also, the terms that occur extremely rarely, right, are also not deemed significant, again, for this LDA algorithm. So you can adjust this. You can play around with this, because the good news is LDA algorithm is not it's not something you need to take over. It doesn't run overnight. It runs in about half a minute or so, even quicker. So it's a relatively quick algorithm. That's pretty good. So you can check filter extremes. You see, you can keep, right? So keep tokens, no below, no above. So basically, so no below, at least, actually 5, I think it's actually at least 5 times. It's actually not correct. I think it's 5. I believe it's 5 actually, right? According to documentation. Maybe it used to be 50, and no above 0.5. So we could adjust this. If you don't like our results, we can adjust it later, right? And another thing is keep 100,000 tokens. Of course, here we only had, I think, 40,000 unique. We have a small corpus here of only 5,000, right? So, and keep tokens none. What is the last one? Let's take our last one. Where is it? Filter extremes. So this is an important part. Keep tokens none. Yes. So you can also specify if something in this filtering list is very important to you. You feel like you need to have some hand adjustment, and you say, okay, this filter is gonna destroy some tokens, some word which you want to keep. You can add a list here of. You can add a list of tokens you really want to keep, no matter what happens, right? It will make sure this function will keep these tokens. You think they are important. Okay, so this is, of course, is for tuning out. So, but it's important to we'll run it. So this will run the dictionary. Can we see the size? Actually, can we see the length of this? Let's check. Look, did I run this? So then, can we have a dictionary? Let's take a look. Yeah, 31,000, right? So what is this? So it is what? It's a dictionary object. What do we have actually? Dictionary. Yeah, it's basically meant for using. It's not a regular dictionary which we learned, not a Python dictionary. It's a specific dictionary for use by Gensim, right? So we can get keys, for example. Yeah, we can get keys and values. Let's say items. It's dictionary with benefits, I believe, right? Items. You can. Let's do first 10, right? Let's see what it looks like. No, it doesn't work. Oh, it's not subscribable. Okay, yeah, I have to do a list. I believe it's items. I think I have to go list. I think I have to do this. But again, it's not meant to be for your. Yeah, you see, extremely in a way it's very simple. It says a word, a token, and its ID. That's all it really is, right? If you want to look inside the engine, so to say, inside your car, right? So it really turns out it's basically just a. So dictionary is just a mapping of. So dictionary is just a mapping of IDs to tokens, right? Again, because ML algorithms most often work with numbers, right? Okay. basically. Okay. So now that we have done all the pre-processing work, not all of it, but most of it we've done, we generate the bag of words. So we're going to generate a bag of words corpus. Now we are going to generate the bag of words for each document. By now you see, again, we use list comprehension. We go through. So again, list comprehension is basically a quicker way of writing a for loop, right? So you go through all the documents, right? And for each document, you convert it to a dictionary doc to bow. So you create a corpus. You create a list of bag of words. So for each document, for each article, you create a bag of words. So let's take a look. What does a bag of words looks like, right? In fact, I have here exactly the same thing, right? Bow, right? This could be, it's exactly the same thing as here, by the way, right? So what's happening here is the same thing here, actually. So let me show you a single instance first, right? What it looks like. We have time, yeah. So single bow, right, would be dictionary, right? Because we have a dictionary, right? It maps these numbers, right? Dictionary, doc to bow method, right? And I'm going to give it documents. Let's do the first one, right? Right? And I think I can print it out, I believe. Let's take a look. Yeah. So not very interesting, right? So basically,
list of IDs.
Yeah, and since this is a first document, the dictionary, right? It's 0, 1, right? It's exactly, there's no repeats, right? So it all tells, okay, so bag of words, I'm sure most of you are familiar with what bag of words is. Basically says it's again how many times each word was in this document, right? So not very exciting here. However, if you do this in a last bag of words, like last bag of words would be dictionary doc to bow documents -1, right? Right, documents -1, last one, right? So last bag of words will be right. So of course the IDs, notice how IDs, so some of these new words, these last 6 words apparently were encountered for the first time. The rest of these words were somehow seen, but there's no duplicates either here. Okay, so that's why I think this will be not, maybe these articles are extremely short. It will be very hard to pick up anything useful out of these topics, right? You would want to have some repeats and so on, right? So again, garbage in, garbage out, but we'll see what happens, right? So now we are going to do it for each document. So we saw how we do it for one, right? We're going to create a list. So we are creating a list of bag of words, right? Yeah, for each document, right? Okay, so let's do that. Pretty quick. Again, it works really quick. Again, same as, so this code, for those who don't understand this, right? This is exactly the same, right? This code is does the same thing, slightly slower than the above one line, right? Same thing. I'm not going to run it. Exactly same, right? This might be a little bit easier to, if you don't feel comfortable with list comprehensions, this standard for loop might be, again, there's nothing wrong with using it, right? Except once you get more comfortable with Python using list comprehensions, it's a nice time saver. Okay. Okay. Yes. So this is okay, but here so far I'll try to see if I can find another example where we have more than one. So in this case, these two articles, the first and the last article, right? Each word is exactly one time. It's basically a frequency, basically, right? How many times? So bag of words means how many times each word was in this document. So a word by ID 1296 was one time in this document, in this particular article. So that's all it is. Why are they not sequential? Because this particular word, right, was in. Yes, exactly. Very good. So yes, we can double check. Of course, we can check what this word is, right? this dictionary, right? Here, right? So let's take a look at what this dictionary is, right? We want to see what this word means, right? And let's double check if that's really the case, right? So dictionary 1296, right? Stundu, that's an hour, right, in Latvian. Okay, so is that really the case? Interestingly enough, they did correctly, right? Notice I use, it looks like a list, but it's not a list, dictionary actually. Okay, so now let's check our last document, documents 1, -1. 5 stundu. Why is, okay, why isn't it, why is this, was this in stop words? That's interesting, why is this missing? Or maybe, wait, of course it might be earlier, maybe it's not ordered, maybe it's ordered by occurrence, so it's possibly, this piecu means it's somewhere else. Again, so when you create a bag of words, the sequence within the document is lost, right? It's just a bag, that's the whole idea. It's a bag of words, it doesn't have a, you can't reconstruct the actual sentence from it, right? It's very highly unlikely you will reconstruct a sentence. It's actually a bag. It's literally a bag of words, not a sequence, right? That's why it's not actually ordered. So stundu, right, is actually it's listed as first. I imagine this is going to be it's going to be let's do this. Yeah, again, it might not be even deterministic, again, because of course these numbers don't really have any intrinsic meaning, right? So it's just a labeling, because these algorithms need numbers, they don't know how to work with, right? Stundu piecu, you see they're reversed, right? Again, so we can see these. I imagine here you will have exact match, right? Because this is the last word in the whole corpus here, right? So this will be exactly, it will match, right? 31686, right? Ziemeļa valstīs, that's northern countries, right? Nordic countries, again, speaking of, right? Baltic, Nordic, Baltic. And again, you can see this in here in a documents, right? -1. Yeah, exactly. In this case, of course, this is the very last word to be added to the dictionary. So in this case, it matches exactly, right, in this bag of words. So you can reconstruct sometimes from bag of words, but again, it's not really meant, bag of words is right, not meant for reconstruction. Okay, so that's why we have prepared this bag of words. Now we can train, well, we're almost, so we have a bag, so we have a bag of, so for to train, this, what is this here? This is, so, is a Jupyter, and Colab, of course, also, and Colab, Jupyter so-called magic command, which times your cell. Of course, Google Colab does it automatically here, right? So you don't really need it if you're using Colab, right? It has built in, but it's more precise. So it's going to tell you how much time you spend, because of course training can sometimes, depending on the algorithm or what kind of machine learning model you use, can take a long time. I have had some algorithms which run over a day, right? And you have to just leave the machine running on a server, right? So this is again, I told you this is a quick algorithm, right? So you won't have to spend so much time. So and this is actually where the magic happens. So what do you need? So you have an LDA model, you have a Gensim library, it has different models, LDA model. So LDA model needs following things. It needs a bow corpus, right? Bag of words corpus. It needs a dictionary, again, which says, okay, this ID corresponds to this word. And then, of course, this is so-called hyperparameter, so-called hyperparameter, which here, which we can adjust, right? And this is, of course, passes. By default, how many passes we have? 1. So 5 is already better, right? And notice by default it's 100 topics. That's too much. If you have 5,000 articles, what's the most topics you could have? You could theoretically have 5,000 topics, right? But that's not very useful, right? Otherwise, you can also have 1 topic, right? But that's also not useful, right? In modeling, right? All models are wrong, but some models are useful, right? So we usually want at least 2 topics, but probably more, right? So passes, right? Again, for optimization. again, if you run it, no need to run too much, right? But 5, 5 is a good starting compromise, right? Compromise. Again, there's such thing as overfitting, right? Sometimes things overfit. Okay, so let's run it. This is actually where we're going to train the model. So we are ready. Everything. Okay, no questions. Everybody's ready. Everybody has their bag of words. Everybody has their. So you need a dictionary. You need a bag of words, which is basically, so this is list of bag of words. So dictionary, right? So really a dictionary. So dictionary mapping IDs to words. So okay, let's run it. See if this works. Okay, and something worked. Something really not. Oh, num topic is not defined. I did not work. I forgot to run this cell. Of course. Where we started doing all this extra stuff. Where's my? No. Where's my topics? Where did I do it? Did I miss it somewhere?
Wait, go back.
Oh yeah, this one. I didn't run it. Yeah, I need to set up these these variables, right? Okay, yeah. We can of course do it by hand, like we have just written in 5 and 7, right? This is not. It's just a good practice because if you need to run again, right, you can adjust the same place. Okay, so let's do it again. So I have num topics, I have passes, everything is ready. Okay, and now it worked. Something didn't work. Okay. What is going on here now? So maybe I didn't do.
You may need to run some cells because you.
Yes. Okay. Yeah. Everything worked for you? Okay. Let me do it again. Maybe I did something here. Let's do this here. Yeah. I think now it works. Yeah. I think I didn't run I did not run the bag of words corpus. I had it, but it's empty. Yeah. Okay. It looks like. So yeah. Okay, so something happened. It took 9 seconds. That's pretty fast, right? Roughly, right? There's some slight overhead for system, 200 milliseconds. But now we will want to see what in the world what did we do actually, right? So we need to have some metrics for evaluation. How well did we do? In LDA, we use something called the perplexity score. So what it is basically, well, it's actually a number of different measures, how well the data in this model, how well these topics actually, how well these documents within topics, how well they mesh together, right? So there are multiple scores, right? So, and again, right, so again, this is, again, reading tea leaves, right? There's an article about this again. It's again, a little bit of science, a little bit of art, right? So again, when it becomes useful to you, that's when you start using it. So, okay, yeah, right, very good. So, yeah, so there are 2 methods. There are about 6 methods in Gensim built in. You can come up with your own, right? You want to have something called topic coherence, right? Again, so how well they stick together, coherent, right? So you can. So ideas, when you do research with topic modeling, you try different number of topics, right? I've run it since it's very quick, 10 seconds, nothing. You can make a loop and check, start with like 3 topics and go up to, I don't know, 50 topics. Maybe do some jumps, 40, 60, 70, and see how the score works. Okay, but we'll see how well did we do here. I'm pretty sure we did pretty badly, right? Because it's not a very, the corpus of 5,000, it's kind of small, that's one thing, and also, again, it's maybe we need to do some lemmas, we need to do some more pre-processing, I believe. Right, so in coherence model, right, so we give it a model, we give our bow corpus, we give our dictionary, so basically we get a score. Right, so we get a score, right, we'll get a coherence score. So let's take how much did we do, and it should be pretty low. Yeah, minus 4.7. So on a scale of this particular metric, UMass, right? It's actually not considered the best metric, but still you can see it's not even over 0, right? So it's not very coherent, right? This 7-topic model, is not very coherent, right? But well, it worked. I mean, it worked. But let's get some results. Excuse me? Yeah, it is not deterministic. It is not so it's not deterministic, right? There's some seed value, so you will not get. For example, I got -5 when I run it before, right? So it will change. No, I don't think it will change right now, right? It will stay stick because the model is already trained, right? But when we are doing training here, right? If I run it here, right, it will be slightly different, right? So of course, if I adjust this to if I change number of topics or I change number of passes, both of these will influence, right? Passes, of course, will at some point it will make slightly more precise the training, but again, at the risk of overfitting on the number of topics, of course, is what you want to really check, right? You want to check. You don't know how many topics are in your corpus, right? There could be only 2 topics, really, right? Again, LDA. Those who are familiar with k-means is also kind of a little bit similar in that way that how many topics you want, you'll get, right? How high? It jumps. The algorithm doesn't know, right? It's up to you as a researcher to determine whether this number of topics is reasonable, right? So there's a rule, but of course it's not all is lost. There's a rule, so-called elbow rule, right? You can check where the topics start going down or upwards. There's usually, you can plot and make a small little scatter plot and see where the coherence score start, moving, right? There's the elbow rule. We'll talk about this a little bit if we have time. So, the coherence, so okay, it's not great, but let's see how do we get it. So, how do we print out, right? So, and the creator of this, original creator of this notebook, you can see he is from the old school of programming. He's using range, right? So he's using range, not using enumerate. Okay, we'll forgive him. So, so basically, get word IDs, right? Get topic terms. You get words. So for word ID weight in word IDs, right? So you get topic terms, right? And it goes through. It creates. It tells you. It picks up these words out of what all this code does. It picks up. Out of these IDs, it picks up the word. So you can see all 7 topics here. We have 7. This is 7, right? So from 0 to 6. So we go through. So this loop goes from 0 to 6. Since 7 is not included in range, right? The number of topics is 7, right? I'll show you, right? Remember the reminder, right? 7, right? So when we get the actual topic terms, right? For example, I could get this, right? Model, get topic. So what's happening underneath here, right? If I do this method, I have my model, right? Terms, and I say 0, right? So these, okay. So what it is? So it tells you this ID, right? Is this important to this particular topic? And of course, it goes down, right? These topic terms, right? It's only showing you top 10. But actually, in LDA, you can have more terms, right? So it's showing only a top 10 here by default, right? And we can check it here. Yeah, top 10 by default, right? But you can adjust it. You can adjust top n. Yeah, top n to see more or less than default 10 terms. Okay, so these are IDs. So let's check. So we saw Gada, right? So if we are correct, this should be Gada, right? Let's take a look at this. So dictionary. We have our dictionary, right? 59. Let's take a look if that's correct. If my correct, Vinch actually doesn't correct. Wait. Ah, here it is actually here. Right, so it's actually not, but it's in here basically, right? So all the scores actually, it's not. I don't think it's ordered here apparently, right? Word ID. Yeah, okay. Word ID and word IDs, right? And then we basically go and we create the list of words. Maybe it's no, it's not sorted, but yeah, they're all here basically, right? So yes, so and then here I don't know, maybe 4 topic terms. Why isn't it topic terms? Let's try it again. We'll see. Okay, we'll see. Okay, right, because of course this was my previous run, so this is completely different. Let's run it. Yeah, it is exactly match. It's exactly match because this is previous run. Okay, yeah. So it works, right? All does this loop is this actually double loop, right? It goes through each topic and prints the top 10 words basically for this particular topic, right? So you can again, if you can do, you can see individual scores for each ID, and of course again each ID is actually a word, right? So you can see 350, right? If you want to see, this is going to be, it should be Kuri, which of course is again not very meaningful word. It might have been a better filtered out again. So this corpus definitely needs some more pre-processing. You see, yeah, Kuri is exactly here, right? So that's the last one. Okay, so yeah, so we went through all topics. We had 2 loops to print them. Okay, but again, it's kind of hard to get a nice. You can do this work. You can of course save this text as a file and so on. That might be good. But there's a really nice tool called LDA visualization, Viz, right? On which gives you a nice interactive graph, right? Very nice. Only I think it does not come. It does not come with Colab, so we'll need to install it, right? We'll need to install it. So pip install LDA visualization, right? So notice the little exclam. This means it's basically a system command, a shell command. So you will install this package, right, on your Colab for now. Of course, next time you run your Colab, of course we will do it again because of course this is just a this machine is going to be gone, right? This particular machine. So everybody's doing it at the same time, but see, it worked pretty well, right? Okay, so we have a nice. Okay, notice it checked all the extra libraries. One of the reasons why pip is so important, also Conda, it manages the dependencies because all these big libraries, they are dependent on each other. So if you need a particular library, you don't want to spend half a day looking which libraries it's dependent on. You want to have the package manager do it for you. That's why these pip install commands are so important, right? So it checks, okay, it needs a NumPy, it needs a Gensim, right? It needs Gensim, of course it needs Gensim because it's meant for visualization of that, right? But it needs a lot of other things, right? So looks like it worked correctly. Again, 90% of time it works. 99% of time actually it works. Checked for pandas, checked for some other things. Scikit-learn also it needs. Right, okay, it's ready. So let's take a look. Can we check? So import, and actually I will check. I will move it. There's also note that this version which we download, it's 3. To check the version, it's actually we can't unfortunately show it on a Colab. We'll have to download the visualization. Do we have a version? Import by Davis. Let's take a look. It worked? Yeah, it worked. There is some warning. Interesting. It did some extra stuff which is not supported maybe in future versions. It's a warning, so it's okay still, but at some future version it will stop working. Let's check version.
Mm-hmm. And there is a question on the chat. Why topic range is only from 0 to 6? Why not 0 to 30, 70?
Yes, but that's what I was talking about. You will have to do it yourself. You don't know how many topics you have. Usually you don't have any good idea. On a large corpus, you will want to go through and check multiple versions. You want to check 5 topics, how well it looks, and check maybe 10, check 15, check 20. And of course, for each of those runs, you want to check the coherence score, right? You want to check, is the number, is this coherence, is this stickiness, is it getting better, or is it getting really bad, right? And again, technically, if you do topics which matches the number of documents, right? You'll have each document will have its own little bucket, right? That's of course it's kind of useless, right? So it does not necessarily high coherence does not necessarily mean something useful, right? If you have just a single bucket for each document, but usually so up to 100, so from 3 to 100 is roughly the usual range, and this is ongoing discussion about topic modeling. How many topics is enough, right? because it's not exact. There's no such thing. Okay, always use 25. There's no such thing, right? You have to. It really depends on your corpus. It's up to you to.
Why then, for example, if you want a coherence score of say 10?
Yes.
Why can't you specify the coherence score and then it picks
Yeah, it might.
the number of passes?
Yeah, but you can. It might not be possible. It might run forever, right?
Really?
Yes, you might not. There might be coherence scores which are not impossible. Which are impossible to achieve. Yes.
Okay, then why can't you just get the, like, why can't it be automated so that it picks the highest possible?
You could. I mean, you could write your own little program which automates. I mean, that's what I actually do, right? You start with these tools and you start to build up some automation into them.
I also wanted to ask whether Gensim doesn't have kind of like iteration of different number of topics.
Yeah.
LDA in R format.
Yes.
It has this implementation.
Okay, this is actually a good question. Maybe there is some extra package in later versions, right, which does do it, right? Because it's such a common. It's like if you look at forums, everybody's okay. How many topics should I pick? Like, what's a good coherence to core, right, and so on, right? So, yeah, it is a. So, but of course, for me, it was easier to just write a loop and check, basically, right? Because that's what computers are good at, writing loops. Okay, so we have version 3.3, and what's the latest one? Was actually, I think that's the latest one, I think, right? We didn't check. Bye. Yeah, that's 4.2, you see? So actually I have quite old Gensim here, right? So that's the thing, right? There might be something which you might be able to improve on. So we have it, right? I don't need to import anymore, right? And there's another thing here. This is also, we need to change, right, the name, right? And we also need to enable notebook, right? So we need it so it works. And let's take a look. So it works. And so it prepares the. So what do we need? We need the model. So model is our LDA model, right? Of course, or above corpse again is our list of bag of words for each document, right? And again dictionary is our mapping of IDs, to actual words. Okay, so let's do it, and it should actually do LDA show, but let's do it. Let's run it. Yeah, it runs. Okay, it worked. So now first we'll save it. So we can do it. Prepare. So this is generated. So this is actually the same thing. Actually, exactly the same thing here. Actually, let's do it one more time, right? So looks exactly the same. Actually, yeah. Well, okay, we'll do it again, right? No big deal. But we are going to save it to a HTML file, right? And then we'll see if we can do it. Show it on a collab. Okay. So it's saved my visualization HTML. Okay, let's take a look. There it is, my visualization HTML. So HTML is, of course, regular HTML file, and we are going to download it, right? We can actually, I think we can open it up also. Yeah, we can open. Oh no, that's not good. That's not good HTML. But we can download it to our computer, right? My visualization HTML, and I can open up in Chrome, right? And there you go. So this is on your computer already, and you have a nice little tiny web page. You can explore the topics at your. I'm gonna make it smaller, actually, right? So it's nice interactive, right? Say which topic, right? 6, 7, right? You can check topics and you see how they overlap. So let's take a look at this. What you see, you can also adjust the relevance, right? I think there's some metric. Yeah. So it shows top 30. So each topic gets, in this example, in this visualization, it gets 30 terms, right? That's enough, I think, right? So for each topic, you have some significant terms. There's police, there's region, something about that. And you can see also some topics. Again, this is not k-means, this is LDA. It's not exclusive, right? So some topics overlap with other topics, right? So some words will be common across multiple topics, right? So it's a probabilistic distribution, right? So here you see that some topics have very similar words actually here. So these 4 topics are sort of grouped together, right? So these are sort of separate, right? So this is something about education, again police, and this is, well, government work. Looks like something about government. So again, this is something about homes again. And yeah, like I said, the coherence is quite low, so these look like, say, again, they don't have to be completely different, but it looks like it's not a great score, right? So you can see some estimates here for how often it's seen, this topic in this term, this token, this word is seen in here, right? So
What's the slide to adjust from?
okay, yeah. So this adjust. There's a reference this somewhere here. Oh yeah, relevance, right? There's a formula for this actually. So saliency, relevance. This is from a paper here. Let's see what happens if we do it. No, like nothing, right? Right. Not very. So let's do 5, right? It's a filter basically here, right? So basically here, the idea is this, right? So here we want these terms are extremely relevant to this particular topic. Turns out it's like reverse here, right? Riga, right? Riga is seen in other topics. It looks like this is a filter for this īpašum, which is a property, right? It is quite seen only in this topic. That's how overall term frequency, right? And this is, so estimate term frequency within the topic, overall term frequency. Okay, so in this, how do you interpret this? So you see within this topic, if you have 0, right? All of these are extremely similar. The frequency in these documents, right, are very similar to overall corpus, right? So not very useful, right? If you have it looks like all the other topics will have very similar distributions. So you probably want this to maximum, right? Because this will be different, right? Overall term frequency will be different from topic frequency, right? So that's more useful, right? That's why it's. Yeah, they will not be really useful. So that might be actually one of the ways. You can maybe see filtering. Maybe you want to do some pre-processing. Maybe delete them beforehand, right? That's a possibility, right? So again, we can jump here. We can jump through, right? This is just a little helper, right? On what else? And again, of course, this axis. What's doing here? You see, it's doing something called principal component analysis. It squeezed all this multi-dimensional feature space into two dimensions, right? So because we are humans, we only we see best in 2 dimensions, right? When you start going over 3 dimensions, it's hard to visualize anything, right? So this is of course not this PC1, PC2. It's principal component. It doesn't really mean anything in particular. These 2 axes, right? Just for visualization. So relevance. There's no other filters, I guess. So yeah. So that's what I actually. Is what one of your your second assignment. First one was to generate a word cloud. Second assignment I want from you is for your corpus generate something like this, right? This type of visualization for your topics. Okay, so now of course we can play around. Let's try more topics. We have a little bit of time, and I still have my voice, I hope. So.
And the assignment is described at the end of the notebook, right?
Yes. So we can actually, I think we're at the end of notebook, right? But we still have time. So yes. So this will be your assignment actually, right? So you, and there's also a form for submission. So you need to submit the workload from a previous session today, right? You need to submit this topic modeling for custom data, right? With your extra code, you might have few cells extra. And then also submit this my visualization, this page, right? It's a single page. This, where is it here? This here, right? It's a single page, right? Yeah, this part here. And again, it is basically we said it here. Okay, well let's try this. Can we see it on our Can we see it here? I saved this, but it should be visible. I think. Let's try this. So P, right, or V is there should be same. Let's check. Is it equal? No, I didn't define it. LDA viz. LDA viz. I think it's exactly the same. Let's see. At least result-wise. I'm not sure. Maybe not. No, you can't compare it. Right. Right. Ambiguous. Right. It's data frame actually. Okay. So type P. Type P. It's a prepared data. Prepared data. Okay. right? Prepare data. So let's see what else can we do with it. I think there is a show, right? There's our option, something generate. Let's see what else. To dictionary, to JSON, to HTML, I believe, right? We use the save HTML. Let's see. And there was a command to show it. And there was a reason I'm not showing. We could show it also directly in a notebook, right? Because it's just a web page. So notebooks are web pages. You can have web pages within web pages, right? So it's possible to do it, but it was not very clean. So that's why I didn't want to. Let's take a look. So Gensim, there was a command. Let's take a look at this. Actually, I mentioned this here. Somewhere here. Yeah, okay, this is Stack Overflow question about this collab, right? It should work on Anaconda. It works maybe on Anaconda locally, but yeah, enable notebook, Viz, right? This should show it. Like I said. Right. Yeah, older version. So this is really old. This is like 2 years ago, but older versions, right? It's 3.3, and the newer versions don't work with Colab, apparently. Again, sometimes it's a regression to have a newest version, right? So let's try this. Will it work or not, right? Can I just do P? Yeah, it works, actually. It does work, to me, at least for me. So I just type P and it works, right? However, again, it's not, again, so since it's a web page within a web page, right? So it's slightly harder to work than a single page here, right? A single page, you have more, right? And you can't really, so it does work directly. So you can in fact run it inside Colab, right? But again, it's usually you want to export it, right? Export this visualization HTML. And again, there's also other options. There are other options. Right, there are other options. There are other options such as save JSON, I believe, right, and some other ones. Right. Okay. So we have our data. Again, let's try. We have some time. Let's try some other topics. Right. So we had 7. So all we have to do is basically, well, we have our bag of words stays the same. Dictionary stays the same. All we have to do is change the number of topics, right? We can also adjust the number of passes, right? We know 5, but 5 looks okay. So, so basically all we need to do is this part here, right? So new model, I'll call it model 10, right? So assignment. Right, I'll do it here. So let's do it. Let's try creating a model with 10 topics, right? But again, I don't think it's a question of topics too much as fact that we need to clean up and we need to maybe do some more pre-processing on the actual data. But okay, so basically 10, right? I'll just do it directly for now, right? And let's see how well it works. Right, model, I'll call it model 10, right, model 10, right, since we want to preserve the older one. Okay, what's happening? What happened? Did I do something wrong? What did I do wrong? Maybe I did something, looks like I did something really bad.
I got the same.
Right, maybe because of visualization. It shouldn't be any problem because we're running again. LDA model, bow corpus is fine. Running it again shouldn't be a problem, right? 10, you gave it 10?
Yes.
Yes. Passes, right? Was it an error or is it just?
It's a warning.
It's a warning. Something we did. It looks like it's an NumPy warning, right? I know what happened. What changed? We added PyLDA visualization, and when we are installing PyLDA visualization, it updated some library, right? It updated, I think, NumPy library, and the NumPy library is saying, okay, in Python 3.7, we are doing some things, we don't do it in later. So what's the issue was that our Gensim or visualization library is too new, right? This one here, this command here, right? we might have been better to install an older version, right? Most basic stuff works in the older version, so this was the issue, right? It looks like it's also, so our training is now slightly messed up. No, so this would be one of the ways, right? So this would be a solution, right? If we can trust Joshi Chan with 70 feedback from a year ago, right? It's a possibility. Again, of course, this is nothing bad, right? This is a good because Colab, right? So you can always, so with pip install, you can specify, right? So you can try installing an older version. Of course, the question is now: will this fix these things? If we install it specifically, will it remove it with pip install?
Not so sure.
No, I'm also not so sure either. Easiest way, what I would do, of course, since it's Colab, I would just restart the Colab, of course, right? I would just restart the Colab completely, right? We rerun the actual, the preparation. We only have all the cells needed. Prepare the data again, right? Read the data. Those cells which read the data, we need to run those again, and then of course we could install.
Or we can ignore the warning and see what happens.
Yeah, I imagine it worked, right? Where is my warning? Where did it work? Did it work actually? Apparently it worked, right? 11 seconds. So actually it worked, right? It's a warning. So warnings mean at some point this feature will stop working, right? You try and do something, right? So it's using an older method basically, right? Unfortunately, it had the big warnings are turned on and it's showing, okay, or it's polluting or model. So, but it worked. Right, it worked. So let's do one more code. And we want to see the coherence score, right? Can we do that? We can, right? Where's the coherence score? Right. So this part here, right? We already imported coherence model, so we have that. Let's take a look. Right, and let's now be careful. So, LDA 100, I'll do it 10, right? On, right, oh no, this is, yeah. Model 10, right? We called model 10, right? Yeah, model 10. So we need to, of course, the names need to match, right? Of course, unless we want to overwrite everything, right? Model 10, right? On, yeah, of course, this also will be 10. So let's see how well did we do, right? So 10. This is this object, right? Coherence model, and get coherence. Let's take a look. Oh, roughly the same. That really is extremely suspiciously similar. Very similar. So nothing really improved, right?
I think it's exactly the same.
Yeah.
The 3.
Oh, I know why. Because I didn't print the right thing, right? You see? Nah, that fixes things, right? So I was printing the old score. So this is a new score, right? So this, it's worse. Yeah, 6. It's getting worse. Okay. So yeah, I want to show you about elbow method, elbow rule, right? K means it's also everywhere else, right? Elbow rule, right? Elbow method. It's used quite a bit in machine learning, but again, it comes from statistics. Where is my picture? I want the picture. Yeah. So you will look for the elbow, right? You want, again, you look for when it stabilizes, right? Whatever it starts somewhere, when it stabilizes some score, right? So either other way or this way, right? When it's stabilized, this is where usually the sweet spot is around here, right? If this presents better, right? So it doesn't get, so you don't want to keep going, assuming this is bad and this is good, right? Theoretically, right? But you don't want to keep going, right? You elbow somewhere, you stop here when it stops the angle stops basically being very sharp, right? Of course, here it looks like it's, we can try 20. Let's try 20. It's going to get really horrible. Yeah, let's try 20. And let me make a, well, I would love to turn off these warnings. This looks like it's certainly, yeah, it's huge. Can we stop again? Yeah, we could scroll it like here, yeah. Yeah, let's try this again.
When you have all the newest versions, there's no warning.
Okay, that's good. Yeah, so you have a newer version of Gensim, right? So that there's no, so that's why, because it looks like this. What's happening is that this visualization library is new, right? However, the Gensim is older, right? Yeah, here we have older, so that's why we have the warnings, because they don't match. And that's, of course, one of the biggest problems is working when you have multiple libraries. Some versions don't match exactly the way you want. Just the warning is good and is not end of the world. It's much worse if you have an error, right? So okay, it gets worse. So try 20. So again, we can do this automatically, right? By the way, right? I'll do 20, right? Topics 20. Again, we'll have these warnings, of course. Again, it's fast. I would love to see how to click off NP warnings, right? It looks like it comes from LDA model, right? We could find this line in the model and turn it off, of course, right? All this. Oh, you have 20 models?
Yes.
All this has 20 models already. What's your score of coherence?
Oh, it's bad, -9 or so.
-9, it's getting worse, right? Yeah, so it's getting worse. So it looks like we don't have very good topics in this particular corpus. Certainly, it's getting worse, right? So maybe even we should have tried maybe, I don't know, 5 topics, right? Maybe it's actually getting, looks like we are going the wrong way. Okay, let's do model 5 then. Right.
3 topics.
3 topics. 5.
No, go with 5.
I'll go 5. Okay, well that's, so let's do one more. And actually, of course, then I guess what we can do is, since we're doing so many times, right? We'll make a function for this. That's what usually you do, right? Well, I guess yeah. So, well, it's actually just one line, really. It's just one line, so you can make a function for this, of course, to make a loop for this, right? So, model 5, right? Again. So model 5, right? Again, we'll have a bunch of all these rows. Whoa, okay. So that looks like the sweet spot, right? That's getting close to 0, so it looks like most meaningful, right? So very good, very good. So okay.
The corpus of uses might be, like economy, politics,
Yes.
technology, so that
Yes, exactly, and that's exactly what would be when you were analyzing these topics. You have to make your human judgment. Again, this LDA is just a tool for you as a researcher to make some idea of how topics are distributed. And again, of course, like I said, the goal for you, I want from you, this assignment is to take your own corpus, right? How big? It's up to you. You want to run it through how big your corpus is, and so, for example, sometimes you do this topic modeling on something you already filtered by some topic already, right? And then, of course, you're sort of modeling subtopics in a way, right? Because you already have, say, you filtered by all news about sports. You have some sports keywords, right? You have a sports corpus, right? And of course, then it's touched to it's harder then, of course, because yes.
What is your feeling for this kind of more homogeneous corpuses? What is the minimum of documents you can actually deal with?
Let's see. I think you need at least 1,000, I believe, roughly. I think so. At least. If you have really similar ones, right? Let's see. How many did we work on? Well, actually, we did work on more. We worked on over 50,000 actually, right? So topics, right? So, but yeah. But the good news is about LDA, of course, is that it's nice. You can play around with these numbers, right? You can play with the size. You can get very quick feedback, right? You can run it through on. Again, let it run overnight. Try different topic sizes, right? And see what's happening, basically. So.
And there's a question here on chat. Some topics are closed. Is there any way to unify them when you already have a model?
Well, that's of course again that means basically you could do, of course, try to just subtract one, right, from the topic number of topics, right? That would be the easiest way, right? See what happens then. But again, notice this space, right? This PCA, right? When you look at this visualization here, right? Again, this is just it sort of says, yes, they are closed, right? But again, this PCA axes, they don't really, I mean, they don't correspond exactly, right? They don't really mean that they exactly, if two topics exactly or closely or much, yes, that's a sign you need less topics. Yeah, it's a good sign then. Yes, but I don't know. I don't think Gensim has a way of automatically. I mean, you could do it by hand. You could check what the scores are, what the number of the words are, the keywords. You could do it by hand, basically, right? You could check, you can extract the meaningful terms, right, and lower it. Okay.
Okay, and one more question here. Can you please show again where we can get
yes,
data files
okay,
for the homework?
Okay, so remember your corpuses are in the, maybe I'll add it here, all right, I'll add it here in the, where is our, we did the filtering with documents, we have it here, right, in the notebooks. Right, these are the documents, not here, corpora, here, right? So let's give you links, right? Maybe all this can give you links, right? These are the 3 links, right? So let's get the Latvian one. I'll get the Latvian ones, right? So if you click, of course, it's big, right? You need the raw link, right? That's a link, right? Or download link here. You can download. So that's the link I'm going to use. Copy link address, right? And let me read the Latvian, the full corpus. Let me read the full corpus for you. So I'll go this, right, and full corpus, right. I'll do it at the top, right, so this is a small, so this is small data set, right, so full data set, control again this, oh, come on, this escape B, these shortcuts, okay, so full URL, right, yeah, okay, so full DF, right, will be pandas read CSV, right? Interesting, if you don't have to specify encoding, it picks up the Latvian encoding, right? And I assume Estonian and Ukrainian as well. So full URL, right? Right, and separator is going to still be the same, right? But we add compression, right? Right, all this zip, right? Like this. Looks okay to me, right?
Mm-hmm.
Well, let's take shape. Let's do shape. This will take a while. And yeah, we have 300,000 articles here, right? That's full Latvian corpus, right? So again, you just change this. So EE and UA, I believe, right? You change that. So change. So Estonian one is at, let's double check if I'm correct. Yeah, UA and EE. This should be more correct. ET, right? All this, right? But again, so EE and Ukrainian one. Of course, if you are sufficiently already have some knowledge, you can use your own corpus. I mean, that also will qualify. You have some other one, but again, because Ukrainian is UA. Okay.
And there is a follow-up question. Can you please explain a little bit more on our homework?
Okay, yeah. So the homework is, so you need to submit 3 things, right? So I want to see the workload from the previous session, right? You have some corpora, right? Again, you can use what you used yesterday, right? And again, I don't want to see my workload, basically, right? That's the main rule. I don't want to see what I did today. I want to see yours, right? So that's easy. Don't need the notebook for that. And then I need this notebook, this very notebook we are looking at right now, but with your code, right? So I want to see some of your code, what you did, right? It's going to be very similar to what we did in class, right? So it's only going to change the way you load the data, the way you clean up the data maybe, right? And then the last thing, I want to see this, right? My visualization HTML again, and I don't want to see mine, I want to see yours, your topics. Maybe it's 5 topics, maybe it's 10, maybe it's 50, I don't know, right?
Can we use the text from like the inaugural addresses?
Yeah, you can do, sure, if you want.
Large enough?
Yes, that's actually fine. Yes, of course. But then, of course, you have inaugural addresses. within the NLTK. I don't know if they are split by address. I don't know how you're going to split them. It's just one big, I think it's one big text, right?
No, you should be able to get
yes.
sentences or tokens.
Okay, yeah, no, yes, you can get sentences or tokens, but for topic modeling, you need documents.
Ah, you need documents.
You can't perform it on one large.
Yeah, because it's just one big doc. I mean, you could figure out, you need some sort of unit of maybe you could have a sentence or paragraph or article, right? Because that's what topic modeling is all about, right? If you have one big article, right? One big book, that's,
Intuitively, there are topics within that book, right?
Yes, but then you need to somehow split the book, right? You need to split the book. So basically, yes, that's when it will work.
So if you had different inaugural addresses
Yes.
by different presidents
then
separately,
it will work. Then it will work. Yes. So you, of course, if you need the inaugural address, I'm sure you could find it. It'd be interesting. Let's do Kaggle inaugural address. I'm sure. Since it's already inaugural address, I'm sure you can.
Is it possible to work with a non-Latvian that you provided, but just not?
Yeah, of course, any language will work, right? So this here, let's take a look here. Inaugural speech is not very big, right? This is the same one, so this is CSV file. This would work probably, right? So you can download, and let's see, can you get a link here? I don't know if you need a login for Kaggle. I have Kaggle login, so. By the way, Kaggle also has notebooks, by the way, also. You can download. Let's see what happens. It's a zip file. Let's take a look what's inside. Inaugural speeches. And I'll open up with edit. Yeah, it looks like it's you see, it's very similar to what we are using. So he has 1, 2, 3, 4, 5 columns. It's a number, a name of the president, right? Address itself, date, and text. A question is what's title of address, where it was done, and the actual text is here, right?
There are not so many texts in those inaugural speeches, no?
Well, they don't seem seem very short actually, right? I think what's happening is that's actually I'm sure, I have a feeling they get bigger as they go along, right? The later.
There is no 1,000 inaugural speeches.
No, it's not, I would say no. This is very small top. Yes, you don't have 1,000, right? You have. Yeah, and so yes, of course. So again, LDA we have 50. Nixon is 50, right? Of course, right? So we get to about George Bush and probably Obama, right? Yes, they get slightly bigger as slightly bigger, right? But they're not too long. Because even Trump here, right? So we don't have Biden here. So let's see here. Of course, they're not that short actually. You notice this, right? This is a. I didn't do word wrap here. This is a regular notepad, I believe. We have word wrap here, right? Yeah. Okay. Right. This I'm using a. Yeah. So then it's still pretty decent size, right? Yeah, decent size for analysis, right? Yeah. Here's the full.
Well, NLTK has Reuters corpus with 10,000 news documents.
Yes.
Maybe that would work well.
So if you have 61 speeches, you could define. You could say again. You can say, okay, you want 4 topics. It'll give you 4 topics, right? For 61 speeches, right? Yeah, it's not very big. I mean, it's more of how big. The main difference is how big each article is actually, right? That's a key.
Another question.
Yeah.
Sometimes there is such a, I don't know, screw alarm.
Yeah.
Said that very long texts are not good for
Yeah. Yeah, that's also true. But also very short texts are also not good for modeling. That's true. So, yeah. So it's again it's not for everything, right? It's not a silver bullet, of course. But yeah. So I hope I was so there's again in order for it to work, you need basically a list of strings which you convert to list of lists of tokens. So each item is basically a list of words, and you feed that to Gensim basically, and it will do a rest for you, as we saw it today. Yeah. So yeah, you can use them again. Yeah. So you have 3 in the form. Let me show you again the form. Right. Submit assignment. Right. So you have three things, right? Name, email again, right? And you have the word cloud, notebook from the last, this is the one we just worked on, and the visualization from today, again. And that's all it really is.
So the question was, where should we submit the assignment? It's this form, and the link to the
link
form
is here. The very last thing is here. Yeah, do you ever receive the link? Yeah. And I can, of course, I could add this link also on GitHub, I guess, but, right. This one here. And let me commit this to, well, all this, I wonder if you can, or artists, I wonder if you can delete this extra cell contents for some cells, right? I would like to just, I don't want to.
You can press on the output.
Excuse me?
You can press on the output.
Oh, where?
double click the output.
Oh, here? It's going to hide it? Okay, no, yeah. I think it did delete it, I wonder. It looks like it did. Yeah, it did.
Or you can press it.
Yeah, it works. So I don't want to commit all my error messages, right? Not not very cool, right? These are not really errors, but they are warnings, right? Again, so I will go up. Yeah, so you can use X to delete the cell contents, but you don't want to, because of course if you did this tools runtime, run everything, right, or restart, then you would lose all the contents here, I think. So let me see here. Yeah, so I'll just delete it. Okay, that's better. Let's take a look before I submit. Okay, that looks good. Let's see if this is actually stays. So I will stay. I'll future warnings. I'm going to get rid of these. Yeah. Well, this is okay. This is okay. Yeah. All right. Okay, here's a link. Okay, so I'll commit this. Day 3 for day 2, part 3. Topic modeling. LDA. Yes, okay. So now if you open up this notebook from Colab, right, or you do git pull or you download it, it should be the latest version. Okay, I think I will stop the recording and upload the recording for now. So every